All right, guys. I think we should start. We have seven. We have five persons. Uh, so I'm seeing I Tony. I Tony is there.
Yes, sir.
All right. Jonathan, Sashay,
Yes,
Rachel,
sir.
and Kimberly. All right. I saw Ariana a minute ago, but I don't know what happened to her. And there was Vanessa as well. Um, what's happening? All right. So what was the last thing we did?
Sir, we
The
learned. I can go, Rachel.
the last thing we did was moles, sir. We learned how to calculate it.
Okay. So yeah, all right. So yeah, last class definitely looked at the mole concept there. So you say we know how to calculate. Now, how do we calculate the number of moles in an object?
Sure, we can use the number of particles
Mm-hmm.
over the Avogadro's number, or the
Mm-hmm.
Avogadro. Or we can use the number of atoms over the. Well, I think that's the same thing. The number of particles is the same thing as the number of atoms, right?
Yeah. Okay. Yeah. So yeah, those two things are the same. So let's summarize this then. All right. So these are the two things then. All right. So using calculate the number of moles using this formula here. All right. And we have here the formula that says that moles is equal to mass over, of course, RAM, or we could call that molar mass as well. And then over here, we could also use the formula as you was mentioning, um, which, right, which we get the number of particles, and so the number of atoms or particles up top here. All right. Then we input here the number of moles. Let's put moles. Just put moles just for simplicity. And then now we have the number here, which is Avogadro's number, which is what 6.02 um times 10 to the 23. And that's what we were doing last week. And then this moles go into this moles here. All right. In other words, it depends on the question that you get. But at least now you should know that these two formulas can be used if the case call for it. So yeah, that's a very good revision from you guys. All right. Was there any other thing else we did? We just did the calculation almost. No definitions, nothing. Um
Sure,
yes.
we got the definition, but it wasn't in the class last week. It was the class before that one.
Oh, okay. All right, very good then. All right. So in that case then let me just bring this up here. Okay. So Vanessa, let's join us back. All right. All right, guys. So we let's look at the syllabus and see where we are then in that case, because the moles it's important to know what the syllabus requires of us. All right. So we got the definitions, as you said, define mole and molar mass. All right. The mole is the amount of substance that contains this number 6.0. They don't just put it to one decimal place there, but all right, that's okay. 6.0 times 10 to the 23, and that's also called Avogadro's constant or Avogadro's number. All right. Now, And then the molar mass they define here as a mass of 1 mole of a substance. Again, this is just a given that you would remember these. All right, now the in terms of activity, they recommend that we observe and compare the masses of 1 mole of different substances. So this would be a lab setting now where we would have to go. By the way, have you heard anything about going back to school?
Yes, sir. I'm having classes on Monday and Friday for agriculture.
Okay. Uh, okay, so Monday and Friday. All right.
There are a lot of teachers are having classes over school.
Was that right, Tony?
So a lot of teachers are having classes over school.
Oh, you mean for which subjects?
So I only heard for clothing and another subject. I think it was 3 classes yesterday, agri clothing and another one.
Oh, but you realize, but those sound like practical subjects though. Um, yeah, so, so some subjects, not all subjects are the same, you know. So if it's like clothing and TD and them and art and them subject they almost impossible to do online. But I don't know what's happening for the other subjects. All right. Really, I was really asking about if it's an official thing, like where them say we're going to go back to school, like you know. But I mean, if you don't hear anything like that, then let's wait and see. All right. We have to stay healthy in the meanwhile. So now we finish in a sense, just finish look over 6.1. Remember the mole concept is the sixth main topic in chemistry. And we look at the 6.1 there. So the well, this now 6.2 is saying that calculations from mass and mole. Uh, so this now from mass to mole, we should be able to do that. This is just going back to the formula that same formula that we just talked about a while ago. You put your moles here, and then if it's mass to moles, then you just use this formula. The number of moles is equal to the mass of the substance divided by the RAM, or in some cases you call it the molar mass. All right, so that's better term to use. All right, and that's what this is saying. And so and moles to mass. So the same formula I'm going to use here as well. So this can use for both. If you because in this case now, let me give you an example. Like they could say for example here, um, a question A could ask you, um, yeah, so determine the mass like of so no, so 1.5 moles of calcium metal. Let's look at two possible. All right, and then they could ask, like the and so this would be like from mass. So this is from moles to mass. All right. This and then the other way could be, which is the more common way. So we could ask a question like, how many moles are there in okay, and yeah, you get something like this. It's 50 grams of calcium metal. So all right, there you go. I mean, the only information you would need that's not given in the question for these two is what? Of course, if you're following, then it would be the molar mass. So we would, and some books write it like this. It's actually relative atomic mass here. So them call it AR. Uh, so AR of calcium. Just put the symbol is actually 40. They would probably leave it at 40 as well. They don't really use gram per mole, but it's the same thing. So you get two questions like this. One is from mass to moles. The other is from moles to mass. Alright. So how do we calculate these? You think you can calculate them? Rachel?
Yes, sir.
Um
Sir, me just a try one little something first, sir. Yeah.
but we're doing the same thing. Why you have to be trying at this stage? We're doing the same thing every class.
So, sir, that would be 1.5 multiplied by 40 for the first one.
Okay. All right. Anybody writing this thing off first of all before I change the screen?
So I'm writing it off.
Okay. All right. So that's you, Kimberly. Ask a question. If what you're going to multiply?
Yes, 1.5 by the 40.
No, 1.5 by the 40, and and why would you do that now, Kimberly? I mean, I want some confirmation of that because we have other students in the class. Let's see if they have the same thing, or let's see if they have something different. If you're waiting on me to work it out, it's not gonna happen today, So you guys let me know when you finish.
Sir, for the first one, when I worked it out, I got 60.
I got 60. All right. Anybody else get the same thing? All right. Nobody else working it out?
Yes, sir. But when I reach the point there.
Come on, that's the first one.